So today you need to create your foldable notes on relative dating. These are going to go in your science notes. And so you have to transform this two-sided handout here into this foldable. And I'm going to walk you through this. So first thing you want to do with this, first of all, you're not going to cut this out in class. This is something you can do later after you've filled in the information. So first thing you're going to do is fold the sides over. So let me pause here and I will be back showing you what it looks like with the sides folded. All right, so this is what it looks like with the sides folded. And like I said, there's no real reason to rush into cutting this apart at this point in time. All right, so we're going to talk about the principle of uniformitarianism. So that's the idea that, well, first of all, what do you think of when you think of uniform? You probably think of school uniform. Well, uniform originally meant same, so that makes sense that we use the word uniform to talk about clothes that people wear that's all the same as a uniform. But uniformitarianism is the idea that all of the geologic processes that happen today, like deposition and erosion and weathering and mountain building and volcanic eruption and plate movement, all of those things that are happening today also happened in the past in the same way. Now, why would you have to write that as a scientific principle? Well, because for a while scientists thought that the earth changed only with big cataclysmic events, and now we know it's these really slow geologic processes. All right, so on the inside then, underneath that flap about uniformitarianism, we are going to add the scientific principle that the same geologic processes that operate today operated in the past to change Earth's surface. All right, next, principle or law of superposition. You know, you think of super as meaning something special or extra, but originally it meant above or on top of. And in this case, we're talking about layers that are on top of another layer, the position of these layers of Earth. So remember, Earth's layers are created by piling on sedimentary layers over each other over time. And the law of superposition says that the oldest stuff is going to be at the bottom and the youngest stuff is going to be at the top. So we're going to fill in here in a sequence of undisturbed rocks. The oldest rocks will be at the bottom and the youngest rocks at the top. Now, notice it says undisturbed. You can have these nice horizontal layers and then an earth force, maybe some continental plate movement, will compress them and bend them and break them, and then they get disturbed. So keep that in mind. All right. Principle of original horizontality. Horizon. The horizon is when you look into the distance and you see where the sky meets the earth, and the line that they make where they touch is a horizontal line. And this principle has to do with when sedimentary rocks are formed, they're always formed in these nice horizontal layers, one over the other. So sedimentary rock layers are originally deposited in horizontal layers. Oops. All right, next, principle of cross-cutting relationships. You can have these nice layers and suddenly some force will crack them and make a fault that goes all the way through all these layers of rock. Or you could have magma push up from underneath and melt its way up through layers and layers of rocks. When those breaks or igneous extrusions occur, that's cross-cutting. And the idea here is that the sedimentary rocks have to be there first before the break happens or before the intrusion of magma happens. So a fault or intrusion is always younger than the layers that it cuts through. And finally, principle of fossil succession. It's just like the principle of superposition in that the oldest fossils are going to be on the bottom and the youngest on the top. All right, so that's the left-hand column of this foldable. So let's go to the right-hand column. So stratigraphy, that's a science. And it's the science of using the layers of the earth to understand time, to understand sequence. So it's the study of rock layers and sequences. All right, next we have relative dating. That's the big idea here today. Relative dating is a method of determining whether an event or an object is older or younger than other events or objects. Now, you guys can understand, I'm sure, about the objects, like that could be rocks or it could be fossils, figuring out which is older and younger by the order that they are inside Earth. But what about events? Well, if you have noticed, the dinosaurs are extinct. And they were basically made extinct by an event that occurred 65 million years ago. An asteroid hit the Earth. It was huge. It raised so many particles up into the atmosphere that these particles were up in the Earth's atmosphere, floating around and mixing, including some radioactive elements. And eventually all of that sediment in the atmosphere rained down over the entire Earth. And there is a layer of sediment when you dig down where you find this sediment, and there are no dinosaur bones above that sediment. All the dinosaur bones that have ever been found on this planet are below that sediment. So that sediment layer tells us about the event, the big extinction of the dinosaurs. So that's an example of how relative dating can help us understand events and not just objects. It can also help us understand I'm drawing a blank, you guys. Evolution, which we will be talking about later. All right, next. Unconformity. Ohio has a huge unconformity underneath your feet. What happened in Ohio was, if you dig into the earth here, you find 0 dinosaur bones. Does that mean no dinosaurs ever lived here? No, it does not. It means that all the layers that held dinosaur fossils for millions of years eroded away. They're no longer here. And then other sediments built on top of the rock. So like between some layers here in Ohio, it's like we're missing tens of millions of years of history in our rocks. That missing place is called an unconformity. So the definition for an unconformity, it's a break in the geologic record created when rock layers are eroded or when sediment is not deposited. Sediment doesn't deposit very well in deserts. So a lot of times, like, there'll be unconformities where there just wasn't any deposition in places. All right, 4 ways rock layers can be disturbed. So over here in the horizontality thing, we said that sedimentary rocks are always laid down nice, horizontal, flat layers, but they can be disturbed, and there's 4 ways. So sometimes earth forces will tilt. So a force will push up underneath one end of a big giant plate or rock and tilt the rock. So we have tilting. And then here, folding. So compression can fold the layers and make them wavy, can even bend them up over each other so that older rocks end up on top of younger rocks, which is backwards from law of superposition. Fault, that's where we get breaks and cracks. And then intrusions, that's where magma comes up from below. All right, finally, we have what is a geologic column and what is it good for? Well, we're going to be studying geologic columns next week in class. The important thing to know is a geologic column is not rocks. It's not like the rocks that are actually out somewhere. It's a drawing or a diagram that scientists make. So it's a sequence of rock layers that contain all the known fossils and rock layers for an area arranged oldest to youngest. So want you to make a note that this is created by scientists. Now, geologic columns are very, very helpful. They're used to study the geologic record. Geologic record, which is, the history of earth and rocks. All right. So now that you got that filled in, if you want to mess around, you're going to cut out these two squares there. See how those squares are missing up here? And then you're just going to cut along these horizontal lines to make these little flaps. And then you can put a little glue on the back. You can glue this into a page in your spiral science notebook, or you can glue it onto a piece of notebook paper and put it in your science notes binder.